Hello everyone, this is Mr. Petrosino going over the Unit 10 review sheet. Keep in mind you're going to have your first online assessment the next A-Day. So if you have any questions after this video, you are encouraged to contact your math teacher, whether it's myself or Mrs. Malik or Ms. Calabro. You are welcome to try these questions on your own and then check with the uploaded answer key, or you can follow along with me. So the first question talks about perimeter. Find the perimeter, which is the distance around the figure of this rectangular deck. So finding the distance around the entire shape, we can simply just add all the sides. If this side is 6, so is this side. Right? If this side is 10, so is this side. So to find the perimeter, 6 plus 10 plus 6 plus 10 would give us 32 feet. Now notice that this dimension is singular. It's one-dimensional because I'm finding distance. Now, algebraically, perimeter for a rectangle, well, there's 2 lengths and 2 widths. So if my length is 10, 2 times 10, and my width is 6, 2 times 6, 2 times 10 is 20, 2 times 6 is 12, 20 plus 12 is 32 feet. So we get the same answer. Either way, whatever you're more comfortable with. Now, applying it to the real world, how much would it cost to put railing around this deck if the railing costs $14.95 per foot? So we need 32 feet of railing, and each foot costs $14.95. So to find the total cost, I'm going to multiply the 32 feet by the $14.95. You can always use a calculator, whether a scientific calculator that you have or on Schoology. 32 times $14.95 would give us a total of $478.40. Now notice if you put into your calculator, it's going to stop at the 4, but we're talking about money, so we want to go to the hundredth place. So the next topic that was covered in this unit is on area. So we have area of different shapes. Find the area, which is the amount of square units, right? Now we're talking about 2-dimensional figures needed to cover a figure of the figure above and the figures below. So let's start off with the figure above. To find the area of that rectangle, right? So to find the area of this rectangle, we're going to multiply the length times the width. So our area would be a length of 10 times a width of 6 would give us 60. Now, in this case, since we're finding area, it's going to be square units. So in other words, there are 60 square feet that can fit inside that rectangle. Now, for the bottom 2 questions, here we have a triangle, and here we have a trapezoid. So for the shape on the left, to find the area of the triangle, we can use one of 2 formulas. You can do base times height divided by 2, or 1/2 base times height. They mean the same thing. It's really just preference, what you prefer to do. If I use the top equation, well, my base is 18 and my height is 6. So I'm just plugging into the formula. 18 times 6 would be 108. And when I divide 108 by 2, I get 54. Now it doesn't give me a unit of measure, so I'm just going to write square units. On the right-hand side, there are 2 ways that we can solve this. First, in the eMath video, they gave us the equation, which is your first base plus your second base divided by 2 times your height. That is one option. Also, if you want, you can just break this down into a rectangle and a triangle, and then you can add those areas together. If we use this equation, well, our first base in this case could be 12. Our second base would be 8. We're going to divide that by 2, and then we're going to multiply it by our height, which is 4. Okay, if you're doing this step by step, keep in mind of order of operations. 12 plus 8 is 20. 20 divided by 2 would be 10. And then 10 times 4 would be 40. Since the unit of measure is feet, it's square feet. Okay, so far we have perimeter and we have area. The next thing we're going to do is we're going to go into circles. And there are a number of things we have to know about circles. One of them is just some of the math vocabulary. So here, if the radius is 6, right, the halfway distance from the center, the diameter is twice the radius. So the diameter would be 2 times 6, which would be 12. Again, since we're measuring distance, single unit of measure, 12 inches. Conversely, if we know the diameter, well, the diameter is twice the radius. So we have 15 equals 2r. How do I get the radius? I'm going to divide the diameter by 2. And you don't have to show this algebraically, I just prefer to do so. 15 divided by 2, the radius would be 7.5 centimeters. That's the diameter is twice the radius. To find the radius, we divide by 2. And then last, an algebraic equation. The diameter is 5x plus 8, so this entire distance across is 5x plus 8. But we also know that the diameter is 43 inches. So since they both represent the diameter, we're going to set them equal to each other. I want to solve for x, find the value of x. So this is a two-step equation. We're going to use inverse operations. The opposite of plus 8 is minus 8. Positive 8 and negative 8 cancel out. 43 minus 8 is 35. And now since 5 is multiplying x, I'm going to divide by 5 on both sides, the inverse. And I get x equals 7. We can always check to see if we solve correctly by plugging the 7 back in for x to equal 43. Another topic that we learned on circles is finding the circumference, the distance around the circle. And we learned that the equation for circumference is pi times diameter. I still remember when I was in middle school, my teacher said, to help remember this, cherry pies are delicious. C pi d. I don't know. If that helps you, feel free to use it. Now for letter A, it's giving us a radius of 4 inches, but we need the diameter. So if the radius is 4, we're going to multiply that by 2 to get the diameter, which is 8. We're going to use 3.14 for pi. So instead of pi, we're going to use 3.14 times our diameter, which is 8. And that would give us 25.12 inches. When you answer these types of questions, see how the directions are in terms of how you should be writing this. If you should be using the pi symbol, if you should be writing in terms of pi, it's going to affect the answer. And then last for letter B, the diameter is already given. So C equals pi times diameter, right? Cherry pie delicious. Excuse me, I already made a mistake. We're going to write 3.14 for pi times 13. And when I multiply those together, I get 40.82 feet. That is the first page of the review. So now on the second page, we still have some circles that we have to cover. But now instead of finding the circumference, which is the distance around the circle, we're finding the area of the circle. We want to find how much fits inside the shape, the surface area of the shape, excuse me. So to find the area, we multiply pi times the radius squared. Again, going back to when I was in middle school, my teacher said, cherry pie is delicious, apple pies are too. Again, if that's helpful, feel free. This time, instead of 3.14, we're going to use the pi key. and we're going to round to the nearest hundredth. So we're going to plug our radius of 3 in. Now, if you feel comfortable, you can do this all at once in your calculator. I'm going to go step by step. So my exponent 3 to the second power is 9, right? 3 times 3 is 9. And when I multiply 9 times pi, I'm going to get excuse me, I'm writing the wrong numbers down. 28.274, and it's going to keep going. It's a non-terminating, non-repeating number. So the 100th place, right? There are 2 zeros in 100. So I'm going to look at the second number after the decimal. Well, the thousandth place is a 4. It's not 5 or more, so I'm going to keep my answer to 28.27, in this case, square centimeters. I'm going to do the same thing for letter B, but now it's given the diameter, and the radius is half of that. So 14 divided by 2, our radius is 7. Area equals pi times the radius, which is 7 squared. Again, you're welcome to do this on your calculator at once, but 7 to the second power is 49. 7 times 7. And when I multiply this, I'm going to get an area of 153.938, and it's going to keep going. The 100th place is the 3, so I look 1 to the right. Since my thousandth place is 5 or more, right, 8 is bigger than 5, I'm going to round that up. 153.94 square centimeters. Last one for area for number 6. This is actually a little bit easier because we don't have to use the pi button on our calculator. Find the area of a circle. Again, area equals pi times the radius squared with a radius of 5 inches. Leave your answer in terms of pi. So you're not going to touch the pi button. Area equals pi times the radius squared, 5 squared. 5 to the second power is 25. And I'm going to put that in front of the pi symbol. Often you'll see the coefficient of 25 before the pi symbol. And you're done. You don't have to write it any more than that. One thing I did notice before or after I squared it off is that this is inches to the second power. We have 2 more topics that we have to cover for this unit. One of them being surface area. Surface area is the area of all the sides of the shape. So imagine wrapping a figure in, let's just say, wrapping paper, or painting a 3-dimensional figure. How much surface area is there? So when we have a cube, right? So when we have a cube, each side, each area, each face is the same. So we can use the equation 6 times the side squared, right? Because there are 6 sides to a cube. So if the length is 7, so is the width, and so is the height. So the surface area will be 6 sides, or 6 faces, times 7 to the second power. Again, using our order of operations, which you often remember as PEMDAS, we're going to do our exponent first. So 7 to the second power, 7 times 7 is 49. And 6 times 49 would give us 294, in this case, square inches. So think of it this way. We need 294 square inches to cover this entire cube. For a rectangular prism, the sides, in this case, are different measures. So the way I do it is I find the surface area as, well, I have a length, a width, and a height. Now keep in mind there's 6 sides, so I have 2 length widths, length times widths. I have 2 width times heights, and I have 2 length times heights, right? We're finding the area of each side, so length times width, length times height, and width times height. And now we're just going to plug into our equation. 2 times 10 times 3 plus 2 times 3 times 4 plus 2 times 10 times 4. Now, if you feel more comfortable just individually finding the area of each side and then adding together, that's totally okay. It's just some extra steps. I'm going to multiply each add-in first. So 2 times 10 times 3 would be 60. 2 times 3 times 4 is 24. And 2 times 10 times 4 is 80. Adding all of my surface areas, 60 plus 24 plus 80, I get 164. Again, since it's surface area, it's square units, so inches squared. So we need 164 square inches to cover this shape. The last topic on your assessment in this unit is finding the volume, the amount of cubic units needed to fill the space, how much can fit inside. So for the rectangular prism, we multiply 3 dimensions, which causes our units to be cubic. We have a length, a width, and a height. Now, if you interchange these variables and numbers, that's okay. The commutative property allows us to multiply in a different order. So a length of 10, a width of 3, and a height of 4. We're just multiplying here. 10 times 3 times 4, which would give us 120. But again, notice now my unit is cubic. How many cubes fit inside that shape? Whereas in surface area, it's how many squares cover the shape. Last, we have a triangular prism. Okay, so with a triangular prism, again, there are a number of ways to solve. A suggestion is to find the area of the triangle and then multiply it by the height, which is, in this case, 22. Right, so I want to find the area of this triangle first. So through eMath, they're recommending base times height, which is a good recommendation. How much is the base? Well, the base is what I'm shading in here. So to find the base of the triangle is finding the area of that triangle, which is base times height divided by 2. Right, notice I put a lowercase b. It's a different base I'm talking about here. 24 times 7 divided by 2. 7 times 24 is 168. And I divide that by 2, I get 84. So that is the area of this triangle, which is 2-dimensional. But I want to make it 3-dimensional, so I have to multiply it by the 22. So 84 times 22 turns this meters squared into meters cubed. Your volume is 1,848 meters to the 3rd power. So this covers all the topics that you need for your next assessment. Again, if you have any questions, please reach out to myself or Mr. Calabro or Mrs. Malik. Some of the ways that I solved may have been a little bit different than how eMath covers it, but again, it's covering the same topics. Have a great day. Hope everyone is safe.